Oh, I have your test here too. Okay. So remember, this is all dealing with trigs, application of trig in a way, or an extension of trig. So we have a radius and we have an angle. So r and theta are the coordinates we use for polar coordinate systems. Um, if you want to plot 2 comma pi over 6, what it means is locate the circle of radius 2, locate pi over 6 on the unit circle, which is 30 degrees, so going counterclockwise in the positive direction, locate that point. That's where it is. And r doesn't have to be an integer value. R could be really anything. You could say r is like 1.9 or 2.1, doesn't really matter. Just you draw it on a circle that would have that radius. So like if r were like 2.5, I put it between 2 and 3, right? P would be pi over there by 20. And of course, the angle doesn't have to be these exact values. I could have said pi over 18 or 25.6 degrees. I don't know. Or 6.7 degrees. No, stop. Okay. Right. Whatever. It could be anything, right? So, and then also it could go backwards, right? So we could go negative angles, right? But if we have a negative r value, then it's delivery of rotation of 180. So if I did negative 2 comma pi over 6, that's equivalent to 2 comma pi over 6. When you have a negative r value, it actually does an automatic 180 rotation. So hopefully that's all just kind of reinforcing unit circle stuff. Of course, if you're trying to say all the possible ways, you can express this particular point. You use 2 pi k. And from here on forward, if we say 2 pi k, we'll assume it's every integer. Unless you want to make it different, then you'd have to tell me that. So I'll put that disclaimer on our next test. Like if you use k, I will assume it's every integer. Unless you say it's something else, then you have to tell me. Hope that makes sense. Pythagorean theorem is what we kind of use to understand how x, y, and r are related. That helps us with the conversions. Of course, basic trig, like tan theta is y over x. That helps us also with the conversions. So converting polar points to rectangular points, that shouldn't be too bad. You can say x equals r cos theta, y equals r sine theta. Or the other way around, you could do inverse tan or r equals the square of x squared plus y squared, all that fun stuff. It can get a little dicey if it's not something that's recognizable from the unit circle. Like, what if your rectangular coordinates were 3 comma negative 4? Then if you have like these side lengths, right? Well, find the legs of 3 and 4. I don't know what that angle is going to be. I have to use a calculator, right? The calculator is going to split this out. Actually, it's going to split out negative 0.297, by the way, not 0.927. So if it splits that out, yeah, because I should have said negative 4/3, but that's okay. But you have to make an adjustment. You have to realize, okay, well, what is that going to be if I rotate from 0 to pi and I stop over here? That reference angle is 0.927, so we'll subtract that from 2 pi, I get 5.356. So you have to be mindful about that because we had that in our previous test, the one not this past week, but the previous week. Yeah. So be mindful about that. Graphing, we talked about graphing r equals 3, just graph a circle with raised to 3. There's no condition for theta, so theta could be whatever. So theta could be whatever you want. So that you just draw a circle with r equals 3. Whereas here, you just draw a line, right? And so that circle is not very clear here, but it would just be like this, where that's just a line. So there's no condition for r. R could be whatever, but theta's got to be pi over 4. And if your r is negative, that's okay. You're gonna still say pi over 4 because it will just come backwards. So that's a-okay, not a problem. So we're good there. Yeah. Yeah, again, if r is like, say, negative 2 comma pi over 4, then you know it's going to be in the third quadrant. Then we talked about I don't think we did, yeah, we did some of this in Desmos, I think. Yeah, r equals cos theta. So what we're noticing now is that the coefficient from the trig function is the diameter, not the radius, it's the diameter. So if you do 2 cos theta, diameter 2. If you put a negative, it flips. Cosine is always going to be symmetric about the polar axis, which is horizontal. Sine's going to be symmetric about pi over 2, which makes sense because sine pi over 2 is 1. And so again, the coefficient will determine the diameter. If it's negative, flips. So in general, r equals k cos theta. That's why k is your diameter. K is positive, then it's going to be going to the right for cosine or up for sine. If it's negative, then it's going to go to the left for cosine, down for sine. It's going to, all these are going to contain the point 0, 0. That's for sure. 0, 0, remember, we call it the pole. Converting, we talked about that. You have to get a little creative. Like if you square both sides for this one, you should be able to then substitute for r squared, substitute for r cos theta, complete the square, get the equation of the circle. Did that for r equals -3 sine theta. A little nasty with the fractions, just deal with it. So hopefully that all makes sense why we would do that. And then graphing, we didn't do example 6, right? No. Yeah. So let's talk about that. Let me do that from scratch. And then you guys have to fill out notes. That's okay if you want to just look at the fill out notes. But if you want to follow along in your blank notes, because you do have the blank notes for these that I gave last week. Does anyone need an extra copy of the blank notes if anyone lost theirs? Yeah, I know you did, Teddy. Yeah, so it's probably best to kind of just look for the blank notes for going forward now. But I wanted to recap. I think that was important to do that. Okay. So let's take a look at how to graph this by hand. Okay. So what do we expect? We expect a diameter. We expect to open right. And we expect the diameter of 6. Okay. Okay. So when you do this by hand, one thing I want to show you guys is actually the order in which, and like, for example, if I were to limit theta, like what if I only did theta from like 0 to pi or 0 to pi over 2, what portion would get graphed? That's the other thing I want to talk about too. We're going to do this from 0 to pi, but what if I limited it? Like we're going to talk about that too. So, and we're going to go in order. So this will be R. Actually, take it back. We'll make theta the left column because that's really my input and R is my output. Even though we list R first and theta second, but I'm going to do it this way. So we'll do 0. Okay, pi over 12. We'll do pi over 6. We'll do pi over 4. We'll do pi over 3. We'll do pi over 2. We'll kind of just keep going like this. 2 pi over 3. 3 pi over 4. 5 pi over 6. And pi. So it's easier to read what I'm doing, these lines. Okay, and that's very basic, unicircle, application here. So cosine of 0 is what? 6, right? So you get 6. Yeah, I mean, cosine of 0 is 1, but times 6. And this will be 3 root 3. You guys see how I got that? Because cosine of pi over 6 is root 3 over 2. 6 times root 3 over 2 should be 3 root 3. Pi over 4, that should be 3 root 2. And that should be 3 because cosine pi over 3 is 1. And then 0. So how's that going to look? So when your angle is 0, okay, so over here, when your angle is 0, let's do, for Monterey, we'll do pink. So 1, 2, those are those cupcakes, by the way. Like yesterday. Here we go. So I think it makes sense. 1, 2, 3, 4, 5, 6. Okay, so that's the first point. So that's what happens first, right? The second thing will happen, it will be 3 root 3. Now 3 root 3, what's root 3 roughly? 1.7, yeah, so about 5.1. We multiply 3. So I'll probably over here. And it is important that you do know the order in which this happens, because we're gonna start doing some more complicated graphs like rose petals, some really neat things, and like cardioids and hearts and things like. But you have to and I will ask like what portion, like what angles you need to get to like the inner loop or to get like this certain petal. So we are gonna have to be mindful of the order of which this happens. And the reason why that matters is because it does matter in AP calculus. You are asked like to do calculus properties on these graphs and certain portions of it. So you actually do have to understand the anatomy of this graph. So the order actually does matter. So 0, pi over 6, pi over 4. Of course, throw in a decimal, throw in a TI-4 calculator. I will argue the TI-4 calculator is actually somewhat advantageous because it's slower, but it actually shows you what's happening. The decimal is just like gives it to you. So I kind of like the TI-4 for this. The decimals can be good too. You can always limit the angles to see what portion is being graphed. Root 2, what's root 2 roughly? So times 3 about 4.2. So probably over here. Okay. And of course, pi over 3 comma 3. And then over here. So when you have your r is 0, you're at the pole, right? When you're at r equals 0, it doesn't matter what the angle is. You have no radius. You're going to be at, it's like the origin. You're going to be at the origin. So does that top half make sense? So when it's graphing, it's going to graph it like this. Even I know it's a circle like this, but I just chose how I want to draw it. But like it starts at 6 comma 0, right? And then starts going counterclockwise. 2 pi over 3. That's going to be what? Negative. Yeah, that's going to be negative 3. Then negative 3 root 2. Negative 3 root 3. And negative 6. Okay. So I plot those points. So 2 pi over 3 and negative 3. So I go down this way. 3 pi over 4. And negative 4.2, so like that. And I kind of know what's happening here. They have that. And that's how the graph is done. So if I go to, let's see here, TI-4 calculator. Now to do in the TI-4 calculator, you go to mode. Always stay in radian mode, by the way. And polar is going to be one of these lines here. There's also a parametric feature. We'll do polar. And hit y equals, it's going to look like this. And if I do 6 cos, and then you can use the x for theta, 6 cos theta. Then I'll go to my window. This will go from 0 to 2 pi. We'll go 0 to pi. The step, what that means is how often it's going to make each of these points. So if you wanted this like really refined, you make the step lower. So that's going to do like a bunch of like dots. Like it's going to plot a bunch of points at every 0.13 theta value. Like we'll play this a little bit. X min, X max, I don't really care. Doesn't really matter to me. I mean, that helps you get the radius. So we can go raise to 10. Okay, that kind of looks like an ellipse, so it's a little confusing, right? Actually not sure how I would update that. I guess you could do maybe make that negative 6 to 6, perhaps. No, that looks kind of crazy. So it's a little deceiving, just so you know. Maybe I can make that. Let's go back to negative 10 and 10. Let's make it negative 6 and 6, maybe. That looks a little more circular. Okay, so be it. But what if I were to make it not as refined? See, it looks like that. It looks more like a hexagon. Kind of interesting. If you want to make it really refined, it might take its sweet little time. So you can actually see the process now. I know it's a little, but if let's say I really make it more refined. 0.0001. It's totally going at a snail's pace. That probably wasn't the best idea.
You can change the speed.
Oh yeah. See, it's Let me turn it off. Yeah, let me make that point. That was not smart. 0.001. That's more reasonable. So now you can actually see the process it's going through, right? So that's kind of a nice feature. So you can see like what order it's going in. And then, of course, if I'm only graphing certain portions, like for example, and this is why it's this is the power polar functions. If I want, like when you guys did piecewise graphs, right? Like you could graph this as a piecewise. I say it'll graph like a certain portion here. But now you could just say, well, I don't really have to think so hard about my domain or range. I just know, hey, if I want like the bottom right corner of it, right? I could go from like 3 pi over 4 to pi. So if I did 0.75 pi to pi, see it just graphs at like that lower right part. So, we have a little more flexibility now with these polar functions. Okay, so I think I kind of beat that one to death. I think you guys understand what's happening here. So we're good?
Yep.
Yeah, okay, good. Converting. Do we do this conversion?
We did the A.
Yeah, for B, hopefully you guys are okay with that. I would expand that first. X squared minus 4x plus 4. But we'll start noticing some patterns after a little while. Because clearly my center is 2, 3, my radius is root 13. We know that now. That's why we did conics right before. And fortunately, these will all cancel because 4 and 9 cancel 13. So that's easy. X squared plus y squared, let's lump that together. Negative 4x minus 6y. Actually, let me push this off to the right side. It might be a good idea. Now, what's x squared plus y squared convert to? Perfect. 4r cos theta. And you do have to be careful about that. I know that on the test, on the number 1, some of you guys like mix up R with sine, sorry, X with sine and Y with cosine. You can't do that anymore now. It worked on the test because you're squaring. It didn't matter. But in this case, it does matter. So we have to make sure we're mindful about that. You do not want to mix that up because you would get a different answer. You can factor in R from the right side.
You also just divide by R.
Yeah, same thing. Sure, that works. R's cancel. So R equals 4 cos theta plus 6 sine theta. Yeah, I don't think I really see a pattern right now of how to just look at the original equation and go straight to polar. But yeah, but if you expand it, use your conversions, you can easily get the equation right there. Lucas?
Wait, units, that's gonna be like calculator.
I don't know yet. I have to look what I do. I think I may I don't remember. I have to also I want to talk to Ms. York because I want to see what she's interested in doing. She may just say, these guys can't be using calculator. I don't know. I got to because they do calculus with polar. I see I'm trying to align with her, so I don't know. So I'll let you guys know. We'll find out eventually. So yeah, good.
Are also zero to that as well.
That was actually that is true. Yeah, but we're not gonna really go with that because that would just be weird. I mean that is true. R does equal 0. But that wouldn't generate that equation. So we wouldn't go with it. Yeah, the answer for this one, by the way, was 18 cos theta. So I think what I'm noticing is that whatever this number is, if I double it and put it next to cosine, or whatever this number is, double and put it next to sine, it looks like that's what's happening. But anyhow, we'll keep on moving. Okay, so we're gonna graph these now, and see what happens. So actually, I'll do this in TI for calculus since I'm already kind of have it queued up. You could do Desmos too if you want. So if you guys want to have a good device out, that's all good. If you want to kind of go through this, but we're going to do this together. So we'll do this page, we'll do this page, and then we're done with the notes after that. Okay, so let's see what's happening here. Okay, so 3 cos theta. I'm going to use my TI4 calculator. So 3 cos theta. And then 3 cos theta minus 0.25 pi. Okay. Okay, and of course mine's going to be a little slow. Oh, and I kind of messed up. Let me switch my apologies. Let me go from 0 to 0 pi. Okay, here we go. So I got my circle coming, right? It's taking a sweet little time, but you know, this gives you enough time to kind of figure out what to do. And then the other one, this is the red, is doing this. And see, part of it goes below like that x-axis. So what's happening here? It seems like they intersect at pi over 4. That would make sense, right? Because if I plug in pi over 4 into the red, actually, is that true? Is that where they're intersecting? Let me think about this. Hold on. No, they're not intersecting there. I'm talking crazy. But anyhow, what I noticed is there's a rotation. That's what I noticed. This graph is rotated pi over 4. Now, what would you expect here? Probably the same thing. Rotated by what? Yeah, negative pi over 3. Right, correct.
What do you mean rotate?
So, the center, I guess you could say.
Oh,
Yeah, actually, that would make sense because if you think about it, let me zoom in. Here we go. Yeah, because see that center is at 1.5, comma 0. That red is probably gonna be at 1.5, comma pi over 4. Also, if you think about it, this dot here is at 3, comma 0. For the red, that's going to be at 3, comma pi over 4. Because when I have yeah, let me label that so it makes sense. So this endpoint right here. Yeah, great question. Like what exactly is happening here, right? So let's go green. So that dot right there is R's 3 and theta 0. That dot right there would be 3, comma pi over 4. Because when I plug in pi over 4 into 3 cos of 3 cos of theta minus pi over 4, plug in pi over 4 into that, I get cosine of 0, which is, and then 3 times 3 is 3. So that's what's happening. Is that you're taking this blue circle, and you're like rotating like this, 45 degrees.
you know, I get the Desmos thing.
Yeah, well, actually, let me show you Desmos. What's going on? If you guys are doing Desmos, and if you do want to do the TI4 calc, this is a free app. It's ti4calc.com. If you want to try that. Now, if you want to do it in Desmos, I would switch to that grid and go from a 0. So just go to the little monkey wrench off to the right. And I think we're automatically in radian mode. Yeah, we're in radian mode. Whoa, what's going on here? Oh my goodness, that is wacko. 0 to pi. And we'll go like say -10. Goodness. 10. What? Okay, I'm just gonna refresh this. This is being stupid. Let's try again. All right, I'm not gonna mess with that. Leave that alone. So R equals cos theta minus 0.25 pi. So what was your question, Sophia?
When I thought 3, 5/4, doesn't show it right.
Oh, so 3, comma. Oh, I mean R equals. Are you pulling the point?
Yeah, that it was.
Okay, so if you do this, if you do 3, comma pi over 4 and hit label. Oh, you know why? Okay. It's actually literally graphing x equals 3 and
Yeah.
pi over 4. So we have to do, okay, I got you here. Yeah, it's actually thank you for bringing this up. So you could do in a general way is you say, okay, well, let's say we do this as what's the right way to do this? A times cos theta, comma b times yeah, sliders. Is that the right way to do it? Hold on, give me a sec. Hold on. I did this like a couple weeks ago. Now I'm totally forgetting. I don't know if this is the right way to do it. Or if I did, I'm trying to think here. Because you want a graph. Okay, I'm gonna cheat. How to graph polar Tesmos. Okay. So it was an input is okay. X equals there we go. I got it. Okay. Okay. So you do X equals wait, no, I thought I had that right. Yeah, okay, I got this now. So do 3 and pi over 4. And it should wait, still didn't show it. 3, comma. Oh, because I forgot because that's off. That's 3. There we go. Okay. Yeah. Sorry, it took me a little while to figure it out. I'll still be right to you, period. So yeah, so what you do is you do just in general terms, you'd write like this.
Okay.
And you use sliders for A and B, and you just pick the parameters for R and theta. Or A is R and B is theta, I guess. And then that way you would see it, right? Then you can see it at that point.
Thank you.
Yeah. Okay. Took me a little while to figure out. So yeah, that makes sense. Okay, cool. Let's keep moving. All right, so we know what's happening. So if we talk about in generalities, what's happening here, it's rotated by K. Cool. Now some other ones we're going to discover. Secant theta and cosecant theta. Now, before we get too carried away and do this in Desmos, what's secant in terms of cosine? Right. If you cross multiply, what do you get? Or x equals 1. Well, what kind of graph is that going to be? Vertical line. And what do you think the other one's going to be? Yeah, because that's r equals 1 over sine theta. R sine theta equals 1. Y equals 1. So, in essence, we know that's just going to be x equals 1. So that's y equals 1. So that's y equals 4, or x equals 2, or x equals -2, or y equals -4. That's all. Pretty straightforward, right? So this is how we are relating trig, things we've done in the past. Make sense of all this. I don't think we need to do some Desmos or TI-4 calculator. I think you guys get the idea. Okay, so in a general sense, we could just say that when I see this here, that's just x equals k. For when you have secant, it's always going to be that way.
Okay.
Well, no, just that's what we expect to happen. So like it's a general sense that like whatever k is, that's what x will equal that. Yeah, you're overthinking it. So, but it's a way we can think of another word to use. I was gonna say generalize, but it's just so it's what we can just assume, put it that way. So in this case, I can say x equals 2. I don't need to really waste my time going through the math, or y equals -4. And that's a really easy problem. I'm not going to ask on a test. It's just so you guys know what's happening. Okay, so the next page is pretty should be pretty easy to figure out. Let me have you guys go through the last page in your table groups. So now you can convert from rectangular to polar. I think I should be able to figure that out now. Now that you kind of know what's happening, right? Just remember, x is r cos theta. Y is r sine theta. We'll let you figure out part C. And also let you figure out 11 and the rest of the page. And I'm going to pick up your homework. I'll be right back.
Yeah, I did. Yeah, nice and warm. You don't want that. This is what
I'll take it. Thank you. I have
And you want to That's right. Yes. Is all you're doing, you're isolating R? Yeah, correct. Yeah, correct.
Okay. So hopefully you see this is going on. R equals 8 over cos theta. probably nicer to write r equals 8 secant theta. Here r equals -12 over cosecant theta. R equals -12. Sorry, that's dumb. Why did I write that? Sorry. Caught myself there. There we go. And then here, remember that's 2 r cos theta minus 3 r sine theta. And you can factor out r. I'm going to kind of skip a step. Write that. Cool. And then here, just rotating. So if you think about it, I know this is x equals 3 now. We know that, right? Or where all come from which part? All of them? Oh, because we know x equals r cos theta and y equals r sine theta. That's a conversion, right? Because remember, x over r, so it comes back to this, right? Like a circle.
Oh. Got it.
Let's go with the circle. No. Okay, so that's theta, right? And that's r. So you have yourself like this, it's like right triangle, right? That's x and that's y. So of course, cos theta equals x over r. That's what x is r cos theta. That's what it's kind of. And likewise with y equals r sine theta. Just that's where it's kind of from. Yep. So what's happening? These are rotated, right? So that means that the slope is not going to be purely vertical or undefined here because it's going to get rotated. So if I were to throw it into Desmos, 3, let's get rid of all this junk here. R equals 3 secant, theta minus 2 pi over 3. Yeah. So you see, it's like, that's what's happening, right? It gets rotated. So actually, it's kind of interesting. I think we'll explore this later in the notes, but if you guys use like a trig identity, you could try converting this. Just trying to think, how would that look? Yeah, you could try converting to the slope intercept form. I'm not gonna worry about that today. Just know it rotates for now. We'll worry about that later. But if it was this, right? And you rotate 2 pi over 3. 2 pi over 3 is 120 degrees, right? So it rotates 90 and it does a little more. So what if I made that pi over 2? Let's say. That makes sense, right? Because if it was like this, you rotate 90, and you go a little more, right? Or what if I rotate it by pi? That's on the other side. See what's over here? But if I do 2 pi, I get back to the same place. So kind of cool. That's what's happening. But that would be kind of a neat conversion to do, but we won't do that today. It's not part of our plan today. And then obviously this also rotates too. So again, that rotates 2 pi over 3. -5 pi over 6. Okay. So the graph is rotated. K radians. And again, it's kind of the same thing, just in general. Same thing. So, okay. I think we're good for today. Yeah. So what do we got? Like 5 minutes? Yeah. Yeah, Charlie, go ahead.
Would rotating something by pi over 6 be the same as rotating positive pi/6, because the line goes through the whole thing.
Great question. Let's look at that. So I vetted 5 pi/6, okay. Plus, well, this is some really weird stuff. No, this looks at it different. So that's 5 pi/6, because it's going the other direction.
Plus minus.
But if I do plus, yeah, it's the other direction. They're parallel though.
What if it was?
Oh, if you did if you did plus
Yeah.
7 pi/6, yeah, then of course, yeah, because you're doing a full rotation. Because negative 5 pi/6, 7 pi/6, the difference is 2 pi. So, yeah, and yeah, there's some kind of like weird stuff's happened there. And yeah, homework is right here. You guys have been working on this for homework. I think it's just anything that says part handout A. Wait, sorry. Yeah, handout A. So you'll graph. Hold on. Is this what? No, this is not the homework I want you guys to do. Wait one sec. Darn it. No, I have to print something else out. Hold on a sec. That's not the no. You have the homework packet, but that's not the homework I want you guys to do because we have not done that yet. Give me a sec. I show it more carefully. I think there's one other sheet I have to print. Hold on to that though. That's a good. It's a good packet. We'll do that next time. But hold on. Yeah, that's a homework.
Yeah.
You all these back?
Hold on to him. Hold on to him. This is the true homework. Let me pick it up.
The tests.
Two tests. Let's take that.
Yeah, that's an effort, but.
Like to be so. Was it where they did first? Yeah. First thing. Sometimes like, yeah. Of course. What do you call it? You know, that English final and that Friday. Oh my god, that's terrifying. I'm so bad at that one. I had to.
Okay, well, this is your homework. It does say due November 8th. That's not true. That was from last year. So but do the source of problems. This is your homework. Yeah, you get this source of problems. You'll probably do some graph paper. So you can probably print graph paper online. I'll provide a link to graph paper. I don't know, not all of them. Like, I think you want, but there's like 90 questions. Yes.
That's your math, I added.
That should have been homework.
Yeah.
It's not possible.
Like, why would I didn't know.
Or no, we didn't.